So, in the tutorial on Thursday, we can do some from question 5, since that was a little difficult. Yeah? But I think the rest were okay. They weren't too bad. Okay. The Remainder Theorem. Okay. Let's take. What was the first question I gave you to do as homework? Did I ask you to do 1G, was it? What was the first one? 1F. 1F. So, just to give you an idea here, when you divided this by x minus 1, what remainder did you get? What was your answer?
Is it what?
1F, was it? I think the remainder is 0.
Yeah.
I think. Yeah? Alright, I'm just checking here. So, trying to calculate the remainder. Yeah, what's 0? Yeah. So, trying to calculate the remainder, it's a long process. You have to do the long division. It's long. So, what we're going to have a look at is there a quicker way to do it? So, we'll go back to this one in a moment. So, what we'll do is we'll say let fx equals ax cubed plus bx squared plus cx plus d, and we want to calculate fx divided by, and I'll just call it x minus k. So what I'm going to do is I'm going to do the long division, and I'm going to see what formula I get at the end. So I'm going to have ax cubed plus bx squared plus cx plus d. I'm going to divide it, and then the remainder here will be my formula for calculating the remainder. So what I'm trying to do is I'm trying to get a formula for the remainder. Do you understand the kind of idea? Right, so I'll wait till you're ready because there's lots of steps here. So this is like the question, and then this is like the answer underneath. So when you're ready, we'll start it then. Okay, not yet. Okay, so what do I need first? Yep. I need ax squared. So that's okay. So that will give me ax cubed minus ka x squared. Okay, now I subtract. So can you see that in green here, these cancel? And what you're left with here is b plus, and I'll just write the a first, ak x squared. Because this minus becomes a plus, and you have b of them and ka of them, so b plus ka in total. Okay, so write that bit down. Yeah. Right, so what's the next part up here? Well, yeah, it would be plus b plus a k x. Oh yeah, and I should carry these down. Yeah. Okay, so I multiply and I get b plus a k x squared minus k times b plus a k x. Okay so far? Yep. So now I subtract again. So again these cancel, and what I'm left with here will be, I'll put big brackets like this, C plus K, B plus AK, close, close, X. So if you watch carefully, there's C here, and there's K, B plus AK, X, and X. So in total, it's this one plus this one of X, which I write here. And then, thank you, the D comes down, plus D. So I know it's getting very big, but the good news is we're nearly finished. There's only one thing left. And that's this big thing here. Plus bracket C plus K, B plus AK, close, close. So now we multiply. So here we get C plus K, B plus AK, close, close, X, minus K times C plus K, B, squeeze it in, B plus AK, close, close. So when I subtract again, what I'm left with is the remainder. So let's subtract. So again, this will cancel with this, and I'm left with the remainder equals D plus K bracket C plus K bracket B plus AK bracket bracket. So you might think, that's not so great. So this is the formula for the remainder.
And D should be 0.
A shouldn't be 0. I think we start at A, don't we? Yeah. Just you don't want the A to be 0. That's all. Because then it's not cubic. But that's not really important right now. Can we simplify this formula? Yes, we can. So let's simplify it a bit. So the remainder equals D plus CK plus K squared B plus AK. So the remainder equals D plus CK plus BK squared plus AK cubed. So the remainder equals AK cubed plus BK squared plus CK plus D. Oh no, does that look familiar? What's this? What is this?
The first one.
It's the first one, but slightly different. Yeah, instead of an X, there's a K. So you end up with the formula, the remainder equals F of K. Let me show you how this works now. Yeah? Okay. So if we go back, remainder equals F of K. So if I go back to the question at the start, here it is here, and let's pretend I don't know the remainder. You can use the remainder theorem. So if this piece here is like the x minus k, then what does the k equal? 1. So the formula says that the remainder is just f of 1. So in other words, you replace the x with 1. Let's see what we get. So this will be 56 minus 25 minus 28 minus 3. When you add it up, you get 0. So you get now the remainder is 0. So the remainder term is a quick way to calculate the remainder without the need to do the long division. Okay. So we'll do some examples, but that's just a basic idea. But let me put the result together a little bit clearer. And you might be thinking, well, what do you do if you have something like something like px plus q, if you have two numbers like this? So just to be clear, if you had 2x minus 3, you use 3 over 2 for the k. So like if you had x minus 1, what do you use for k? 1. If you had x plus 2, what do you use? Minus 2. And then 2x plus 3, what do we use? 3 over 2. Okay, this is just how to switch them. So anyways, this is the result here. Well, actually, yeah, this is just the result here. Remainder is f of k. Okay, so let's have a look.
Can we go up, please?
To how far now? To here?
No, for
The little
the
example.
example.
Oh, it's very, 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 very rough example. Is that what you thought the remainder theorem was? Just like this? Yeah. Yes?
Yes.
Yes? Yes? Yeah. Okay. Let's have a look at some examples. So something easy first. If 5x minus 1 is a factor, then what is the root? Okay, so if 5x minus 1 is a factor, then what's the root? Does anyone know?
1 over 5.
Yeah, x is 1 over 5. But what about if we go backwards? If I say 5 over 3 is a root, then what is the factor?
2x minus 1.
Let's have a look. Yeah. So the answer here is 3x minus 5.
Can you repeat again?
Yeah, there wasn't much to repeat. I suppose the way I'm doing this in my head is, if you just look to the side, I have 5 over 3. That's like the x. So then you have like 3x equals 5. So 3x minus 5 equals 0. So this here is the factor. And the other one, what was my other one I did? 5x minus 1. In my head I just went like this. 5x minus 1 equals 0. 5x equals 1. X equals 1 over 5. That's all I did, yeah. Can I go back?
Yeah.
Yep. Okay. So let's use the remainder theorem. So let's see. I want the remainder when you have 18x cubed minus 71x squared plus 28x minus 1 divided by 2x minus 7. So the remainder should be 18, 7 over 2 cubed minus 71, 7 over 2 squared plus 28, 7 over 2 minus 1. Now, calculate time. Let's see what we get. 18 bracket 7 over 2 cubed minus 7 bracket 7 over 2 squared plus 28 bracket 7 over 2. I cleared it. Oops. 18. Did I make a mistake? Is that a mistake? No?
No, no.
Okay, good. 18, 7 over 2 cubed minus 71, 7 over 2 squared plus 28, 7 over 2 minus 1. So I got a remainder here of minus 1.
Why you use the root? Why you just use like minus just 7?
Why did I use which?
Why you use the root? What if you use
Yeah.
like
Yeah, what if I use like, yeah?
7 only?
Yeah, now, this goes back to when we have x minus k. If there's no number here, yes, we can use 7. But if there's a 2 here, then we have to use 7 over 2. I didn't...
Because when you use like, get the formula there.
Yeah, this formula here, this is when the factor is like this. You know? If you have a factor like, let me call it, I don't know, px minus q, you have to make some correction because of the p here.
P must be 1.
If p is 1, then you can use q. Yeah. No, in my proof here, in my proof here, it's like I had 1 in front. Yeah. So if you want to make it the same as the proof, it's almost like you have to take the p out. Here, let me try and show you on the side. I'll just write here for a second. So what I did was I did this. But what happens if I wanted to do like this one? What letter will I use? P maybe, yeah? So that's like this. Take the P out. Yeah. And then something. Yeah.
Like if you divide
It's like
if it's 1, so it give you the same effect.
here.
Yeah.
How best to explain?
Like divide them separately.
Yeah.
X over b, another one x.
It is a bit like that. It is a bit like that. That will do. Yeah. So it's almost like I'm just looking at this problem. Yeah. It's also a bit messy because if I had something like this equals 0, okay, that is exactly the same. It's the same as this. Like if you look at this, what answer do you get here for x? X is 1. And what answer do you get here? A half. And for this one? 1. And this one here? A half. So even though if I multiply this and multiply this, what's here and what's here will look very different, but they have the same answers. And in fact, if I divide this, by 2, I should still get 0. And if I divide this by 2, I should still get 0. So what I'm trying to say is, it's okay to take the p and put it underneath here for dividing. The remainder theorem gives you the right answer. That's a terrible explanation, I know. It's terrible. But I hope you're happy with it. You see, he didn't say he was happy with it. It's okay. I understand this. Alright, can I go on to the next example? Yeah? I suppose, if you really, really, really wanted to, what you could do is you could do this proof again with a p here, and when you get to the very end, no, I'm not joking. You can do this proof with a p here, and when you get to the very end, you'll get this answer instead. So if you want some extra homework, you could see if you get that. Yeah. But I decided not to put the p there because if I put the p here, what would I need to write here firstly? No.
A over B.
Yeah, a over p. And that is ugly. Yeah. So we won't be doing that. Okay, next example. So this is kind of more what you get in the exam. Find, let's say, p if x minus 3 is a factor of 2x cubed plus px squared plus 21x minus 18. Right, so the key word here is factor. Okay, so if it is a factor, what do I know about the remainder?
Zero.
Yeah, because I said it's a factor, then I know that the remainder must be 0. So therefore, 2 times 3 cubed plus p times 3 squared plus 21 times 3 minus 18 should equal 0 because the remainder is 0. So now it's not so difficult to get the p. This will be 3 squared is 9, so that's 18. Oh yeah, thank you. So that is now 54. So 54 plus 9p plus 63 minus 18 equals 0. So, thank you. P is 11. Minus 11? Okay. Yeah? Yes, yeah, that's okay. Alright, let's have a look at it. Something like this, a little bit more difficult now. Right, can I scroll down? Yeah. Right, so for example, also just to be clear, if this was in the exam, this would be like a section A question, because it's shorter. So this one is a bit longer, it'd be part of a section B question. So, let's see. When px cubed minus 26x squared plus 71x plus q is divided by x minus 1 and x plus 3, the remainders are 9 and minus 3, 6, 3 respectively. Yes. Yes, indeed. Okay, so we'll do it now. Okay, can we start it? Yeah. So what I'm saying here is if you take this cubic and divide it by x minus 1, you get a remainder of 9. And if you take the cubic and divide it by x plus 3, you get a remainder of minus 363. So I want to find the p and the q. So I'll just break this up into two parts. So I'll look at this one first, and then I'll look at part 2, the green one here. So let's look at this one here first. So if I divide by x minus 1, that means the remainder is 9, which means that p times, what do I put in here to be cubed? 1. Minus 26, 1 squared plus 71, 1 plus q should equal 9. So let's just clean that up a little bit. So that means, therefore, p minus 26 plus 71 plus q equals 9. So you get p plus q equals 9 plus 26 is 35. 35 minus 71 is going to be 35 minus 71 minus 36, is it? Let's double check that. 9 minus 71 plus 26. Yeah. Okay, so does it make sense how I made that? Now we'll look at the plus x plus 3 part. So if I look here, so this is like the first part of it. So if I look at the second part, the remainder should be minus 363. So that means p, and then what do I use for x here? Minus 3. P minus 3 cubed minus 26 minus 3 squared plus 71 times minus 3 plus q. Let me move this a bit. Should equal minus 363. So let's clean this up a little bit. Whoops. Minus 27p. Now this will be 9 times 26. Minus 234. Minus 213 plus q equals minus 363. No problem? Which one do we think is wrong? None of them? It's okay? So you have minus 27p plus q equals minus 363 plus 213 plus 234, 84. Okay? Yeah. So what do you think we do next to solve the p and the q? Elimination. Just put the two together. In fact, you don't have to do much work because the q's are already the same. So if I just minus here, minus 36. So that would be 28p, they cancel, equals minus 120. Rats. That ain't good. Means I made a small number mistake somewhere. Yeah. Anybody spot my mistake? Little help? Alright. Firstly, make sure I wrote the question down right. Yeah. Yeah. So I used 1. Okay, this one looks right. What about the second one? 3 cubed is 27. 3 squared times 26 is 234. 71 times 3 with a minus 213 q equals.
Well, it's alright.
What? That's bad. No, there has to be a mistake somewhere because my numbers aren't working out. So they can't both be right. Don't know what I wrote.
Can you change the question?
Yeah,
It's
the
not
question is
71.
wrong.
Yes, I can. It just means I'll have ugly answers.
Yeah, it's okay.
Okay, we can live with ugly. Good, good. Right. So here we get P equals 30 over 7. Yuck. And and it's minus as well. P is minus 30 over 7. And then if you sub that back in here, you can get the Q.
Negative 222 over 7.
Minus 222 over 7. Alright. When you get this question in the exam, of course, there's nothing wrong with these answers. These are perfectly fine answers, but usually in the exam they at least make these answers whole numbers, not fractions. But it's not like it's wrong, it's just that it's ugly. And there's nothing wrong with being ugly. Okay, can I go to the next example? Yes? 15x squared plus 13x minus 6 is a factor of px cubed plus qx squared minus 45x plus 18.
Ah.
Okay, you got that? Okay, can I do this one? Yeah. So what's the problem with this one? I mean, what makes this one so difficult compared to the last one?
You have to factorize it first.
You have to
The cubic.
factorize the quadratic. Yep. So you can let's try and find the factors here. I'm going to be pig lazy and cheat. Right. So you have 3x minus 1, and then 5x plus 6. So this is a factor of px cubed plus qx squared minus 45x plus 18. So what's the next step now?
Get the roots.
Yeah. Of what? The quadratic?
No, the two linears.
Yeah, that's it. The roots here and here.
Yeah.
Yeah, and then next?
Get like if this equals 0 and
Yeah. So you get, let's say you got the
substitute the two roots there.
substitute the two roots here into this.
Yeah.
Yeah. And then you make two equations. But am I allowed to do that? For example, I know that this is a factor of this, but do I know that this is a factor?
Yes.
Do I?
Yes.
Why do I? This is my question. Why? Like if I tell you this is a factor of this, then you know that that divides into that, and the remainder is 0. But if I tell you these two multiply together as a factor, do you know that this and this, they're both factors independently, separately? Well, this is my question. Do we know that or don't we know it?
Yeah, we know.
Yeah, you're confident that we know.
Just pick any numbers.
uh,
And we multiply them.
yeah, okay, so your example is with some numbers. So good. Let's see what happens if we do it with numbers. So let's say something like
15.
yeah, okay, 3 multiplied by 5 is 15, and let's put it on the top with, let's say, 30. So I say 15 is a factor of 30. When I divide it, what's the remainder? It's 0, isn't it? Okay. Now what about 15? You can write that as 3 multiplied by 5. Yeah? Can we do 30 divided by 3 and 30 divided by 5?
Yeah.
Yeah, we can. So as you said, if together they're a factor, then each part is a factor. But if you want another way to see it, if how many roots or how many factors does this cubic have? It'll have 3, won't it?
Yeah.
Yeah. And I know that this is a factor, so I should be able to divide it, right? So when I divide it, what am I left with? I should only be left with 1. So that means one of these must cancel with one of these, and the second one must cancel with the second one. So again, in other words, it is right to say in this case that each one is a factor. Okay, so let's have a look at the first one. P 1 over 3 cubed plus Q 1 over 3 squared minus 45 1 over 3 plus 18. What should that equal? 0, because it's a factor, it means no remainder. 1 over 27p plus 1 over 9q equals, let's clean this up. That's a 15 there, isn't it? So it'll be 18 plus 15. Yeah, 33. I think so. Is that okay? So next, what's the next value I use? Minus 6 over 5. Cubed plus q times minus 6 over 5 squared minus 45 times minus 6 over 5 plus 18 equals 0. So here you get 6 cubes. 216 over 25 p cubed with a minus plus 36 over 25 q, and then 18 minus 6 over 5. So that's a minus on the left, a plus on the right. No? Mistake? 125. Thank you. So, yeah. So, I think this will then equal minus 36. So they are not pretty. No. What do you think would be the easiest thing to do to solve these? What multiplication do you think now? What should I put here? Multiply by. What do you say? I think if I multiply this by, look here, if I multiply this by 25, I will cancel the 25 here and make 36 on the top. I would like 36 here as well. So I would need to multiply this one by 324. Because if I multiply 324 by 1 over 9, I'd get 36. Yeah, that's life. So multiplying, I get 324. Now what's nice is 324 multiplied by 1 over 27 is actually 12. And 324 multiplied 1 over 9 is 36. And then 324, wait. Okay, here multiplying by 25. So here I get minus 216 over 5. And then next I get 36q. And then next, yeah, kind of need that later. P here, and then 36 times 25. So that's minus PQ. What's wrong? What the heck is that cube doing there? It fell. Alright. Okay, so let's put these together. Minus 12 minus plus 216 over 5. So you get 276 over 5. P equals 10692 plus 900. 11592. Oh yeah, P is exactly 210. So I can put that back into, which one now be the easiest one? Maybe just about the first one. If I put that back in there, I can get Q. So 1 over 27 times P plus 1 over 9Q equals 33. Okay. So you have here 210 divided by 27 is 1 over 9 times Q equals 33 minus 70 over 9. So I get here Q equals 227. Yes? It's long, but it's the same type of question. It's just long. Yeah? So just to show that this is the answer, let me put P and Q back in. Okay. Loading. In the exam, I don't think you'll get questions as difficult as number 6, but I have seen questions like number 5, the last example I did, many times. Okay.
Typical time for this question.
Which one?
Like this question, 5 minutes?
No, it can be a little bit longer than that, yeah. I don't know. For this in the exam, maybe 8 minutes. Yeah. Px cubed minus 26, no. What is it? Px cubed plus qx squared, is that it? Hey,
minus 45
help me out here. Minus 45x
plus 18.
plus 18. Okay, what did I say the value for P was? Let me put it in. So P was 210.
210.
Okay, and what did I say the Q was? 227. Okay, so this is what the quadratic looks like, cubic looks like with P and Q in it. So you already know two of the factors. What are they? You had it, what was it? 3x plus 1 and 5x plus. So when I factorize this, I should see two of those there. Simplify, factor. Okay, did I type it in wrong? Do I have the signs right? Were they both positive? I thought one of them was negative. Which one was negative? Was one of them negative? Was it 210 or minus 210?
And then 15 and minus 33. So isn't it?
Oh, right.
So can you go back? Minus 33.
Yeah. I don't know if this is wrong or this is wrong. I know. Hey, we'll check here. What did I say was my first, what was my quadratic? 15x squared.
Plus 13x minus 3.
Alright. So here,
Simplify.
alright. So 1 over 3 and minus 6 over 5. So let me put that in for x. So x is 1 over 3. So I get this equation, but it should equal 0 because it's a factor, so equals 0. Alright, and then the other one, minus 6 over 5? Alright. Minus 6 over 5.
Equals 0.
No. Yes. Hold on. X is minus 6 over 5, not Q. Alright. Now that looks like what I got as well, wasn't it? Oh wait, hang on. Are you sure? I don't remember a 3 there.
Equals 0.
This looks a bit suspicious here. Did I write 33?
Yeah.
Should it be 3? It's looking bad now. Alright, let's see. Alright. Oh yeah. Oh, what a scandal. Minus 3?
Minus 3, yeah.
Alright, so you just need to fix this and then fix everything after it. Problem solved. You'll pass, yeah? Yeah, now you see what happened? I was tricked by the beauty of the answer. I thought this is definitely right, I have no fractions. Okay. Like I said, this one here is a little bit too difficult for the exam. So I'll give you one to do, but from that question, but it can be optional. Alright, so number 1, G, and then G,
Can you say it again?
G, well so far it's just been G.
Yeah.
No, yeah. G for all of them.
G for all of them.
And for the last one, if you want to do it, you could just type B. If you want to, that is. Oh,
Is this due for tomorrow?
Say that?
Is this the homework for tomorrow?
Yeah. But I'll let you start them for a couple of minutes, yeah. So you can work on these for a few minutes and then we'll start the next lesson, okay? So the next lesson is not too difficult. We're going to be trying to draw the cubic. Oh, didn't you like drawing your quadratic?
No.
Shame. Alright, try these for a few minutes and then we'll start the next one. Can I close this?
Yeah.
Yeah. Destroy the evidence.